section here is separation of two or more liquids from a mixture. So what you are noticing here is, so here because we are saying two or more liquids, the first point what we have to understand is you have to select a mixture which contains liquid in liquid, liquid dissolved in liquid. Select a mixture liquid dissolved in liquid. What are the examples you can take? That is alcohol in water, alcohol in water, both are liquids. So alcohol is water, alcohol is liquid, and also water is also liquid. Alcohol in water is a liquid, number one. Number two, that is milk in, you can take, that is milk in, or else you can take oil in water. Take oil in water. Oil is liquid, water is also liquid. Similarly, go for, that is benzene in water. Benzene in water. Benzene is liquid and water also is a liquid. Benzene molecular formula is C6H6. Kerosene in water. Kerosene in water. Yes, liquid, and this is also a liquid. That is acetone in water. Acetone is a liquid. This is also liquid. So like this, if you are going on taking, so number of examples you can take. Mercury, sometimes we take mercury plus benzene, mercury chloroform plus benzene in water. All are in liquids. So what is the concept involved in all these examples? If you take in all these examples, what you are noticing is, we can say in some cases there is a boiling point difference, and in some cases there is density difference. In some cases there is a boiling point difference, and some cases there is a density difference. For example, if you take this example, if you are taking this example here, I can say the boiling point difference. You can find that there is a boiling point difference between alcohol and water. For example, alcohol boiling point is 78 degrees centigrade, water is 100 degrees centigrade. Boiling point of water is 100 degrees centigrade. So you can find the difference in the boiling points. Similarly, if you take oil in water, means it is again based on the heaviness of the particles and lightness of the particles. Actually, density of oil, here you can take the difference, that is density. Here you can take density of oil is less than density of water. Density of oil is less than density of water. That's why we say oil floats in water. You take benzene in water. This is point of miscibility and immiscibility. Again, here you can take the solubility again. That is mixing, mixing you can say, because both are liquids. So we have to simply say mixing or miscibility. This is immiscibility. I will use the word immiscibility. Benzene is not soluble in water. So based on the solubility difference, I can say solubility difference. You are finding that this is solubility difference. Here also solubility difference. Take the solubility difference. Here also acetone in water, again boiling point difference. Boiling point difference in these two cases. Here miscibility and immiscibility. Miscibility and immiscibility. difference. So taking this, wherever you find that there is miscibility and immiscibility difference, separation method is through separating funnel. Funnels for those mixtures which are miscible or immiscible. Of course, miscible you can directly take the distillation method. Actually, wherever if you take immiscibility actually, frankly speaking, immiscibility is used for separating funnel, and miscibility you can use for distillation method. So whatever may be the case, this is one case. Then if you go for, that is distillation method, if you go for distillation method, yes, the mixture, that is two solutions in the form of mixture, if they are miscible and homogeneous, they should be miscible, homogeneous, and if they have boiling point difference, we can use the distillation method. So all this we can take it into account, and we can carry out the process of the distillation method. That means here separation of two or more liquids from the mixture, we have two methods. One method is distillation method, another method is separating funnel method. Two methods we are trying to adopt here. Separating funnel method we are adopting, and we are also adopting distillation method. So here let us apply the method. Fractional distillation method, for alcohol and water mixture of solution. Because both are liquids, we are trying to apply the mixture of solution in the form of alcohol and water. So what is the principle involved here? Fractional distillation means it is, what is the principle involved here? Principle is boiling point difference. Boiling point difference between two liquids. Point number one. What is the boiling point of alcohol? The boiling point of alcohol is 86 degrees centigrade, and the boiling point of water is 100 degrees centigrade. So here one thing what we have to notice is boiling point is inversely proportional to vaporization, or you can also add one more point. Boiling point of a given liquid is also can be understood in simple terms as evaporation. That means what is the generalization you can make from this relationship? We can say that is liquid during fractional distillation, liquid with low boiling point. Example, alcohol already has low boiling point. Ethyl alcohol has low boiling point of only 86 degrees centigrade. Is going to distill, is, you can put it in this way, distills over first, then followed by that liquid which is having more boiling point, then it is going to get distills over later. So let us do one small experiment here. What I am doing here is, just you take one distillation flask. If you consider that this is the distillation flask, this is going to be the distillation flask, and here we have a mixture of alcohol and water. We have alcohol and water. Alcohol and water, it's a mixture. Then here you just take a tripod stand. It's a tripod stand, and here you try to supply the heat source of it, Bunsen burner. This is heat supply. Heat supply. So here take this, that is distillation flask. This is distillation flask. Then for this you fit a rubber cork in such a manner that it is given one more glass pipe like this, a glass tube like this. In this we are filling all the glass beads, which gives the necessary cooling effect. Then from here we just pass a condenser. This is cooling pipe. It's a cooling pipe, and finally the distillate is collected. This is a cooling pipe. The water is being circulated here. Cool water. So here a small rubber cork is placed for the connecting link between the this is a glass pipe. These are all glass beads, which gives cooling effect. These are all glass beads, and here these are all cool water circulation, and this is nothing but condenser. We can say that this is a condenser. It is a condenser. So here what is happening here is, first alcohol boiling point is 86 degrees centigrade and water boiling point is 100 degrees centigrade. Because of the boiling point difference, you find all the alcohol vapors almost reaches the topmost region of the glass bead pipe, the glass bead tube. Because here the temperature is lower temperature, all the vapors they enter into the cooling pipe, and because of the continuous circulation of the cool water, the alcohol vapors they start getting condensed, and slowly the vapors start getting converted into liquid, and these liquids they roll over and you get the pure alcohol. Then followed by the water. Again you separate the water and again you heat it to a temperature of 100 degrees centigrade. Finally water also gets cooled, and finally you are going to get the second distillate. So the first fraction, so from this experiment, first fraction is alcohol, and second fraction is water taking place.
If you like this video,
The
please
next part
give
of
a
the
thumbs up.
discussion.
Please subscribe to our channel to get more videos on CBSE syllabus.